Hello and welcome to my science tutorials. In today's video, we are going to be looking at the IUPAC nomenclature of alkenes, or how to name alkenes. Before we begin, if you are new to my science tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. So what then are alkenes? Okay, so alkenes are unsaturated hydrocarbons. Okay, alkenes are said to be what? Unsaturated hydrocarbons. That is, they have what? Double bond. Now they have the general molecular formula CnH2n for what? N greater or equal to 2. So it means the simplest alkene that we can get has what? N is equal to 2. So it means if N is equal to 2, let's see. So if we have C2, H2 into bracket 2, which is equal to what? C2H4. So this is the simplest alkene that we can get. So if N is equal to 3, then we have what? C3, H2 into bracket 3, which is what? C3H6. So this is the simplest alkene, followed by this, and then it goes on like that. Now alkenes have the functional group of what? This carbon double bond carbon and this. So this is the functional group of alkenes, and then the bond angle between these bonds is what? 120. The two carbons involved in, or the two carbons that have the double bond are what? They are sp2 hybridized. Okay, and then like I said, the bond angle between these two bonds are what? 120 degrees. Now with this basic intro to what alkenes are, let's have a look at how we name them in case we are given some to name. So let's look at the first example. So we have this to name. Alright, one thing we want to know is that we have some prefixes that we use when we want to name compounds in organic chemistry. So for one, or when we have one carbon, we say what? Mate, or the prefix mate. When we have two, we have what? It. 3 is prop. 4 is what? But. 5 is pent. 6 is what? Hex. 7 is what? Hept. And then 8 is what? Oct. And then it goes on. Now, like we said earlier on, we said alkenes what? Their least number of carbon that they have is what? 2. So it means we do not have methane for alkene. No, this does not exist. It starts with what? Ethene, or 2 carbon atoms. So when we look at this, if we expand this, we have this. Then we have the double bond carbon, this, and then this. So we can see we only have 2 carbons, so we use the prefix what? It. Okay, but because we are dealing with what? Alkenes. Okay, we are dealing with alkenes, we add the ending ene to the prefix, so we have what? Ethene. So this compound is called ethene. Let's have a look at another example. So we have CH3, CH, double bond, CH2. So let's write this, let's expand it. So we have this CH3, then we have carbon with just what? 1 hydrogen, then double bond, another carbon with what? Hydrogen, and then what? Hydrogen. Alright, so if this is the expansion of our carbon, we can see we have what? Carbon 1, carbon 2, carbon 3. Or someone can count in the opposite direction. Okay, carbon 1, carbon 2, carbon 3. Alright, let me use my first color. Alright, so if this is our compound, and then we have the double bond over here. We can see that we have 3 carbons, so it means what our prefix is what prop. Okay, but then we need to specify the position of the double bond what in the naming, so that someone will not be confused. Okay, so for this one we can see that the double bond is what on carbon 1, so we say what 1 propene. Okay, but normally we just say propene, because even if the double bond, if someone is to write this whole compound again as what C, let's say C H H, or someone inverts this compound, so we have C with the 2H over here, then we have C with an H, and then we have the CH3 at the ending. We can see that still in naming, this will be our carbon 1, this will be our carbon 2, this will be our carbon 3, or 1 2 3. So either way we are going to take the one that will give us what the least locant as much as possible. So we will still have what 1 propane. So some people just ignore the 1 and just write propane, because whether you change it or you don't change it, you are still going to get what propane. So this is propane or 1 propane. So whether you say propane or 1 propane, you are still right. Alright, let's have a look at another example. So we have CH3, CH2, CH, double bond, CH2. So let's expand it. So we have CH3, then we have CH2, then we have carbon with an H, then we have the double bond, carbon, H, and then H. Alright, so we can see that we have 1 2 3 4, 1 2 3 4. We have 4 carbon atoms over here. Let me use another color. So if we are counting in this direction, you have what 1 2 3 4. So in both cases what we have what 4 carbon atoms, so which means we are using what bute. So it means our parent name, okay, for this compound is what butane. Now we need to specify the position of the double bond. So this is where it gets interesting. We can see that if we use the blue counting, our double bond will be on what carbon 3. Okay, so we are going to have so we are going to have what 3 butane. But then if we use the red counting, that is from here, our double bond will be on what carbon 1. So we are going to get 1 butane. There is supposed to be a hyphen over here. Now when we are naming, we always try to give what the least number to the double bond as much as possible, either the double bond or the substituent. We try to give it what the least number. So instead of writing 3 butane, this is not 3 butane, we use what 1 butane, because we give the least count to the compound or the double bond. So the blue counting will not work, but then the red counting will work in this case. So this compound is what 1 butane. So let's have a look at more examples. All right, another example that we have over here. So we have CH3, CH bonded to what CH3. Then we have another CH doubly bonded to carbon with what CH3. Then we have CH2, another CH3. So let's expand this carbon. So we have CH3, that is this over here. Then we have carbon with what hydrogen and then CH3. Then we have this carbon with what hydrogen, and then it has double bond with carbon, and then this carbon what has CH2 CH3, and then this one has what CH3 over here. So let's go ahead and count the longest continuous chain. So if I'm using the blue counting in this case, so this is our carbon 1, carbon 2, carbon 3, carbon 4, 5, and 6. So let me count in the opposite direction. So we have 1 2 3 4 5 6, because this is going to be our longest chain. The chain can curve in any way, so this is our longest continuous chain. So we can see that we have 6 carbon atoms. So it means our parent name is what hex. So we have what? Hexene as our parent name. Now we need to give the least number or the least locant to the double bond as much as possible. Now we can see that if we are using the blue counting 1 2 3, the double bond is on what? Carbon 3. So we have what? 3. So we have 3 as our locant. But if we are using the red counting, we have our what? Our double bond on what? Carbon, let me see, red 1 2 3, also on carbon 3 over here. So whether we use the red or the blue counting, the substituent will be the double bond will be on what? Carbon 3. But then we need to take note of something now. So if carbon 3 and carbon 3 are both working for us, we need to consider another option, that is what? The substituents that we have on the carbon. Okay, the substituent will now determine whether we will use the blue counting or the red counting. What do I mean by this? If we look at this compound critically, we can see that this compound we have over here, let me use another color to highlight that. We have this compound, okay, and then this, okay. They do not form part of the parent chain, so they are called what? Substituents. Now for these substituents, we need to also give them the least locant as much as possible, because in both cases the red and then the blue are the double bond are on carbon 3. So we need to consider the substituents that we have over here. Now if we are using the red counting, we can see that we have the first substituent on what? Carbon 2. So we have 2-methyl. Now this is what we call methyl. Now the second one is on what? Carbon 4 for the red counting. So this is what? 4-methyl. Okay, now if we are using the blue, this is for red counting. Now if you are using the blue counting, we can see that this is carbon 1, carbon 2, carbon 3. So it's on what? 3 carbon 3, or so we have 3-methyl. So we have carbon 4, carbon 5. So there's the second substituent is on what? Carbon 5. So we have 5-methyl. Now if we sum the numbers over here, we get 6 for this, we get 8 for this. So we said we want to go for what? The least locant, or the least number possible. So we are going for the one that is giving us 6. So which means we are choosing what? The red counting in this example to name the compound. So if that is the case, it means what? We can say our parent name is now what? 3-hexene, and then we have 2 substituents, on one on carbon 2, one on carbon 4. So what is the name of this compound? The name is now what? 2,4-dimethyl. Okay, because they are all methyl, we need to say what? 2,4, then dimethyl what? 3-hexene. So this is the name of this compound. Or someone can write 2,4-dimethyl what? Hex 3-ene. It's still the same thing, whether you bring the 3 in between the hex and then the ene, or you bring it before the hex and then the hexene, is the same thing. Once you separate your numbers by what? Comma, and then number and a word with dash, then your name is correct. So let's look at more examples. Alright, so we have the compound CH3, 2, CH, CH2, CH double bond, C, we have chlorine, then CH3. Alright, so let's expand this. We have this carbon, then we have 2 CH3s attached to it, then we have our hydrogen here, then we have this carbon with 2 hydrogens, then we have this carbon with just 1 hydrogen, and then double bond to a carbon with what? Chlorine, and then what? CH3. Alright, so let's look at how we count. So this is our longest chain. So we have carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. Alright, so someone will also count in the opposite direction. So this is our carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. Now if we can see that aside the longest continuous chain, we have some other group of atoms that do not form parts. So we have this and then this, so they are what our substituents in this example. Now if we are using the red counting, okay, the red counting in this case, our parent name will be what? 1 2 3 4 5 6. So we have hex, and then our double bond is on carbon 2, so we have what? 2 hexene. Okay, now our first substituent is what? Chlorine, and it's on carbon 2, so we have 2 chloro. Then we have our second substituent is on what? Carbon 5, so we have what? 5 chloro. Okay, so it means what? This compound, someone using the red counting will give it the compound this name. So the person will say this this is methyl. Okay, so someone will say this is what? 2 chloro 5 methyl what? 2 hexane. Now someone using the blue counting, okay, will say my first, okay, this is what? The double bond is on carbon 4, so the parent name is what? 4 hexane, which already you can see that the red counting is giving us 2 and then the blue counting is giving us 4, so already this naming is already wrong. But then let's continue and see. So if we go that way, we can see that the substituent, the first one will be on what? Carbon 2 over here, so we have what? 2 methyl, and then what? The second one will be on what? Carbon 5, so we have what? 5 chloro. Do we see that if we use the substituent, the sum of the substituent is what? The numbers is what? 7 7, but then the position of the double bond, which is of primary importance, is what we are using in the naming over here. So this is 2 hexane, this is 4 hexane. We want to go for the least one, so we are going for the red counting in this case. So our name is what? 2 chloro 5 methyl 2 hexane. All right, so now let's look at how we name dienes in case we have 2 double bonds in a compound. How do we name them? So let's start with the basics. So we have CH2 doubly bonded to carbon, another what? CH2. Now we can see we have carbon 1, carbon 2, carbon 3. This one, it doesn't matter where you count from, we are still going to get the same thing. So if we are using this, the first double bond is on carbon 1, then the second double bond is on what? Carbon 2. So we have 1 2, this is 1 2 3 3 carbon, so this is what? Propane. So we write propane, and because the double bonds are 2, we use the word what? Diene. So we just add diene to this, so diene, and then this is the name of this compound. So the name of this compound is what? 1,2 propane diene. This is D. All right, let's have a look at the second example. So we have CH2 double bond CH, single bond CH, then doubly bonded to what? CH2. So if we do the counting, so this is carbon 1, carbon 2, carbon 3, carbon 4, 1 2 3 4. So we can see if we are using this one, we have double bond on what? Carbon 1, and then double bond on carbon 3, this way to carbon 1 then carbon 3, so it's the same thing. So we have 1 3 what? This is 1 2 3 4, it's 4 carbon atoms, so this is what? Butane. Okay, and then we have 2 double bonds, so butane what? Diene. The 1 3 shows where the diene is, or the double bonds are, so it means the first double bond is on what? Carbon 1, and then the second double bond is on what? Carbon 3. Let's have a look at one final example. So we have CH3 CH double bond CH, then carbon with what? Chlorine, and then double bond CH2. So if I expand this, we have CH3, which is this, then we have carbon with hydrogen doubly bonded to another carbon with hydrogen, then bonded to a carbon with what? Chlorine, doubly bonded with carbon with what? 2 hydrogens. So let's see if this is our carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and then someone using the other way will say this carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Now if we are using the blue counting, we see that our first double bond is on what, carbon 2, then second one is on carbon 4, so 2 and 4 is 6. If we are using the red counting, we have the first one on what, carbon 1, and then the second one on what, carbon 3, so it's 4. So we go for what, 4 instead of 6. So we are using what, 1, 3, or the red counting in this case. I don't know why, or instead of blue being the correct one, I'm using red counting a lot in this tutorial. Alright, let's go ahead. So it means our parent name for this compound, okay, is going to be what, 1, 3, then we have 5 carbon atoms, so it's what, pentane what, diene. Now we can see that we have a substituent over here and it does not form part of the parent chain, so it means what, we also give it that number, which is what, 2 chloro. So if we combine these two, it's going to be what, 2 chloro 1, 3 pentane diene. So thank you so much for watching. This is how we name alkanes with both just 1 double bond and then the dienes with 2 double bonds. So thank you so much for watching, and then I'll see you in the next video. Bye bye.